We have just completed module 14 in the context of sample survey. Now, we are going to take up module 15. In that again, we are going to discuss the problem of estimation of the size of a finite population. This topic we have touched in the text by talking about capture, recapture method and allied methods. Here again we take up the same problem, but with a big difference. The formulation of the problem is a novel application of some graph theory and networking. We will see how the formulation goes, how the solution comes, everything is novel, and the idea is still continuing. There are a good number of research components and research issues blended in this topic. So, with this brief introduction, let us go for the main text. So, I propose to discuss a very special topic in this module. As I said, this again refers to estimation of the size capital N of a finite population, but with a difference in the following sense. The population units are not directly accessible. It is not like a household survey or industrial survey like that. The population units are not directly accessible. Instead, there is a reference population of say capital M units, and all the ultimate population units capital N, they are linked to the reference population units through a well defined network. Let us take an example. A community of households, and we are interested in the estimation of the total number of adults who are severely drug addicts in that community. So, I have a community of households, but my purpose is not to count the number of households etc., but we want to know what is the estimate of the total number of adults who are severely drug addicts in this community.
Sir, I can see that it will be a futile exercise to check the individual HH households and try to identify the victims of severe drug abuse. On the other hand, I believe it's quite likely that they are registered with rehabilitation centers located in the region. These centers may then act as the units in the reference population you're mentioning. Am I right, sir? Yes, I can also see that a network is possibly defined and formed by the registration of the ultimate population units with the reference population units. There is also a possibility of a multi-center registration for some or all drug abuse victims.
Very good. I am very much impressed by your thinking up to this point. Yes, as you can imagine, if we can scan through all the reference population units and if we have access to all their registers, then we have 100% numbering of the ultimate population units captured, because nobody can escape through the registers. Naturally, then the question is, what if we decide to sample only a few of the reference population? There are too many reference population units. We do not have time or resources to go for 100% inspection. We take a part of them. We can sample that, and through that we can establish a network, and then we can try to do something.
Sir, let me try to figure out. Since the reference population is a finite labeled population, we can define a sampling design over this population and draw a sample of RPUs. For simplicity, we may adopt a SRSWOR's design. These small m sampled RPUs will deliver a sample network exhibiting their connections with some of the UPUs as captured by the sample collection. In the process, some of the UPUs will be observed along with their networking with the sampled RPUs. With this well-defined but limited data, the problem before us is to propose an unbiased estimator of capital N. It is indeed a challenging problem, I think. So, this unbiasedness criterion is a catch. Without any such qualification, one can possibly suggest a reasonable estimator. I'm tempted to propose one such from common sense. Capital M divided by M times the number of ultimate population units so captured in the sample of small m reference population units out of capital M reference population units. This is simply stated and worked out, easy to explain and convince the user, but what about unbiasedness? I'm sure there is no justification toward that.
I am again impressed by your mature thinking, of course, but what you said is a very common sense thought, and one would argue as you have thought out, and of course, unbiasedness is a point to ponder about. This topic has drawn the attention of researchers for quite some time in the past. In a doctoral dissertation in 1976, there was a mention of this problem, and the researcher also provided a highly non-trivial solution. Much later, quite unknowingly, in early 90s, there has been a study along similar lines. The topic has picked up momentum now, and we find a renewed interest in this topic in the 2000s. My purpose is to give you a taste of the thought process in resolving this problem of unbiased estimation of the size of a finite population whose units are not directly accessible. That is the, in brief, that is the problem that we are trying to address, and we are going to provide some thoughts on unbiased estimation aspect. So, for simplicity, let us start with a hypothetical population network involving capital M equal to 6 rehabilitation centers, as we thought, catering to the acute need of, for example, 10 highly drug addicted adults in a small neighborhood. So, this is my population of 6. As I go through them, I open the registers and I find that altogether they involved 10 highly drug addicted adults in the neighborhood. So, there is a population network there, and this is the network that we are looking into. So, rehab center 1, 2, 3, 4, 5, 6, individuals 1, 2, 3, 4, etc. 10, Y means yeah, present there, etc. That is the network.
So, as I can see, this network is self-explanatory. The first 3 victims are registered with the rehab center 1. One of them is also registered with the rehab center 2, and moreover, this center has an additional 4 individuals registered therein, and so on. The entire network shows the eventual networking status of all the 10 individuals. Hence, 100% inspection of the rehab centers will capture all the 10 individuals. At this stage, you're asking a pertinent question. In the absence of any knowledge about the network, how would we provide an estimate of capital N if we are exposed to a sample of rehab centers chosen accordingly to a given sampling design?
Yes, this is the challenging problem. You are very right. If I am exposed to all the rehab centers, then there is nothing. I can have a good idea about the population network, and I can count 1, 2, 3, I go up to capital N, that is the end of the story. But if I am exposed to a part of the rehab centers, then naturally I am exposed to a part of the population network. Then how do I go for projecting to capital N? That is exactly the problem. Okay? We will look into an answer to this question by adopting without replacement sampling, for example. Okay? So, we think of selecting a sample of 3 rehab centers out of 6. To be specific, suppose I have done this random sampling and I find that my random sample captures the centers 1, 3 and 6, for example. Therefore, I refer to the network connection. I go to rehab center 1, they open their register, I find out how many people are registered there, and I take their names and I give some serial number 1, 2, etc. I go to the next one, there could be something common, something extra. I go to the next one, 6, there could be something common with 1 and 3 and something totally new. So, I have a good idea about the sample network through 1, 3 and 6.
So, let me try to assess the information content of the chosen sample. We have 3 sampled rehab centers, 1, 3 and 6. Individuals captured 1, 2, 3, 3, 4, 5, 6, 2, 7 and 8. We must first understand the data. Rehab Center 1 has a registration of 3 patients, and these are labeled above as 1, 2 and 3. Next, Rehab Center 3 captures individual 3 and also 3 more individuals designated 4, 5 and 6. Finally, Rehab Center 6 captures individual 2 and 2 new individuals labeled 7 and 8. So we must note that these labels are exclusively based on the networking as encountered through the sampled rehab centers 1, 3 and 6. Thus, we have captured a sample of 8 individuals through the process of sampling. What would be our estimate of capital N now? Very interesting, and at the same time very much a challenging question. So please don't leave us in the middle of our curiosity.
No, I want to do that. But before that, let me also tell one thing, that the way we have marked 1, 2, 3, 3, 4, 5, 6, 2, 7, 8, The only information that we have here is that we have reached up to 8. Suppose I started by going to the rehab center 3 first, and then going to 1, then going to 6. I could visit them in any order, only the naming would be changed. What I am saying as 1, 2, 3, because I visited the rehab center 1 first. If I started with rehab center 3, then these 3, 4, 5, 6 would have been 1, 2, 3, 4, just a matter of alert. It all depends on how, in which direction, in which order I am visiting the rehab centers. But the idea is that there is a network no matter how I do it, and I can reach up to 8. That is the point. So, it is a good problem, as you can see, it is a good problem, challenging problem. At this stage, I will only give an answer to the question without giving any proof of the claims that are being made. So, there are 2 scenarios, one is called probing, other is called no probing is allowed. Let us see what is the probing. What if the sample based captured individuals in the ultimate population units, that means the drug addicts, they respond to probing like this. So, the data collecting agency, the interviewer or the agency, they enter into a probing with the individuals who have been actually captured through the network. Hello, I am conducting a study to the effect that etc. I had access to the records of some of the rehab centers, namely etc. I got to know that you are one of these people etc., victim of this, and that you have registered yourself at such and such. And further, you are not registered at the other places, because this is my limited knowledge about your registration. I had a sample of 3, I have been on in all the 3, I find you registered in 1, but not in the other 2, or maybe I find you registered in 2, but not in the other 1, or maybe I find you registered in all the 3. However, it is only based on my records of the 3 rehabilitation centers 1, 3 and 6. Would you mind disclosing to me where else you are registered out of the remaining centers? The centers which are not within the purview of my study, just tell me where else you are registered. I would highly appreciate your releasing this piece of information to me.
Sir, another alternative would be the investigation agency prepares a list of all the ultimate population units so captured through the sample network, and then the agency approaches other unsampled RPUs and requests for release of the names of any of the registered ultimate population units already covered by the sample. That would also be the same as what we're looking for. Yes.
Yes. That is also a probing in some sense, either directly or indirectly. Either you approach them, the individuals, or you approach the other centers and tell them to release information. Basically, you are trying to get information on whether the people who have already been captured through the sample networks, whether they are still associated, registered in other networks. That is the kind of information you are asking for in the other places. But it is not clear whether the other places they would really oblige you, because they know that they have not been selected for releasing any kind of information to you. So, it is not clear whether the other unsampled RPUs are supposed to cooperate with you or not. If they do, then of course, you can as well go to them and ask for this information. But whatever way, we have some information now. This is called the probing. So, if probing is allowed, with the knowledge about probing, now we have this formula. What is my estimate of capital N? Capital M by small m, that is the fraction. Capital N is, that is the number, capital M is the total number of rehab centers and small m is the number of rehab centers captured, multiplier. And what is small hi? Small hi is for the ith sampled ultimate unit, in how many out of those small m rehab centers the person is actually registered, that is the number hi. And after probing, it shoots to capital Hi, the number of ultimate, the number of these RPUs, the rehab centers where the person is actually registered. Small hi is the actual sample network based RPU score, and capital Hi is the probing score. If I call it score, it is a score for the ith captured ultimate population unit in the sample network as well as in the entire population network through probing. So, my probing effort yields capital Hi, my sampling effort yields small hi for every unit I who is captured in the sample. Is that clear? And small n is the number of units covered in through my sampling effort. Clearly, capital H I is at least as large as small h I, and small h I is at least 1, otherwise that person would not show up in my sample anyway. So, this is my estimate. One can just, it is not difficult to justify that this is an unbiased estimator of capital N.
So, further to this, I think it also follows that capital N hat is always more than or equal to N. Yes, I can deal with some specific situations like when the HIs are equal to M, or say capital HI equals capital M, situations like that.
It is very tempting to feel that that type of result should hold unconditionally, whatever be the nature of the population network. It turns out that in most general form, N hat may turn out to be less than capital N, and I mean less than small n, that should have been small n. Okay? However, in most applications it satisfies the desired inequality, namely N hat greater than or equal to small n. Further, there are results on under the probing formulation, one can write down an expression for the variance of N hat and expression for the estimate of the variance. These are available in the published literature. So, there is a typo here, this should have been small n. Okay? Next, for situations wherein probing is not effective for some reason or the other, if they do not cooperate, they say sorry, whatever it is, that is it, we cannot go tell anything more or anything less, fine, that is it, whatever you got, that is it. We have meager data, and this time is really problem. All I know is capital M, what is the number of rehab centers, small m was my choice, number of rehab centers that I have selected, and through my sampling effort, how many ultimate units I have captured, that is number of small n. Now, for every unit I in my ultimate unit in my sample, I know out of small m in how many he or she is attached. That is my data IHI. So, this is the meager amount of data that I have. Now, the expression for N hat, if at all there is an unbiased estimate of capital N, far less transparent. Even the result, not the proof is even more difficult. Even the result itself is very difficult to visualize. So, this is coming from a dissertation in Harvard University in 1976. So, to compute capital N hat, you go through the following steps. Step number 1, you use these small h I values I equal to 1 up to small n to develop a frequency table. Small h I values you start with 1, 2, 3 etc. up to small m, and then you can find out frequency count. Work out a frequency distribution of the small h I values, call it JFJ 1, F1, 2, F2, 3, F4, 3, F3 etc. etc. And those FJs they will go only up to m, and summation Fj is equal to small n. So, you know you can think of a frequency distribution. Naturally, there will be some missing terms, because you want Fj to be strictly positive for every admissible j. It could be 1 with some F1, 2 with some F2, there is no 3, then again 4 with some F4 and so on. The nature of data will be like that. And then for every j where if j is positive, you compute a quantity called Aj 1 plus minus 1 to the power j plus 1 times a ratio of two things. One is factorial divided by factorial. So, these are the terms involving only capital M, small m and the running index j, and that j is coming out of the frequency distribution that we have made out of the HIs. So, HIs have been used to come up with a frequency distribution. Once you have the frequency distribution, you have the count Fj corresponding to the level j. Based on the level j, you have this number Aj computed, and your N hat is summation Aj times Fj. That is the quantity defining the proposed to be an unbiased estimator of capital N.
Sir, I can see that this result is highly non-trivial. I have no idea about generating these AJs based on capital M and small m alone. I would like to take up the illustration that we started with and see for myself how the computations go. I would like to consider both the scenarios. With probing, we have these values for I and HIs. Then N hat is approximately equal to 9.
Yeah, let us try to understand this data. Since that you mentioned about you want to take up both the scenarios, this is the case with probing. So, the idea is that the unit number, the individual in the among the ultimate population units who has been labeled as 1, that individual was found in only one of the 3 sampled rehab centers. And when that individual was probed as to additional number, the person said, yes, I am also in one more which is not sampled yet. Therefore, the number capital H1 turned out to be 2, whereas small h1 is 1, capital H1 is equal to 2. That shows that out of the 3 sampled, the person was attached with 1, and out of the 3 non-sampled, the person had attachment with 1 more. That makes 2. Like that, the individual who has been labeled 7 in the sample, the ultimate population unit labeled 7, that person was attached to one of the rehab centers in the sample. The person is attached to 2 more out of 3 non-sampled. That makes the number H, capital H7 equal to 3, whereas small h7 equal to 1. That is the interpretation of the data. And then you apply the formula as it showed, and capital N hat is roughly 9. We know the true population network has 10, it is roughly 9.
Without probing, we have capital M is 6, small m is 3, and small n is 8. Then step 1, j and fj's are 1, 6, and 2, 2. Step 2, a1 is 2 and a2 is minus 1. And therefore, n hat is equal to 6 times 2 minus 2 times 1, which is 10, more than 8.
So, here interesting thing is that they are talking about, so because there are 8 individuals and there is no probing, so we are looking to the classification of the small hj values of these 8 individuals, and 6 of them they have singletons and 2 of them they are in 2. That is without probing the data that I have. That means, the data that I have over here, the first part 1, 2, 2, 1, 1, 1, 1, 1, that is my data. If it is without probing, only the first one. So, that is what has been. So, 1 has a frequency of 6 and 2 has a frequency of 2. That is all that we are showing, 1, 6, 2, 2. And then immediately you need to compute A1 and A2, that is it. Apply the formula, you get A1, A2, put into the formula and you get 10 more than 8. So, as you see, these are easy computations, however, it is not all that gold. It is not at all clear if n hat without probing indeed also satisfies the desired inequality n hat greater than equal to n. As a matter of fact, no matter how exciting the formula for capital N hat is, it turns out that capital N hat so computed may often turn out to be negative. Not only weird, but it could be large negative, large positive, all kinds of scenarios are there. This suggests that research in this specific area is still not totally satisfactory. So, you are able to provide, this itself is a very important theoretical discovery. Yes, without probing with this meager data, you can come up with an estimate of capital N, you can come up with a theorem which says that under such and such without probing condition, given the data, this capital N equal to etc. serves as an unbiased estimator. That itself is a highly non-trivial solution. But the question is that when it comes to computation, it may turn out to be negative, largely negative or largely positive. So, therefore, the research in this specific area is still not satisfactory. Maybe we should do away with unbiasedness and think of something reasonable, some reasonable estimator, which will at least ensure that capital N hat is greater than or equal to small n for every conceivable sample and sampling procedure. At least that is the minimum that we expect. And then it should have reasonable property in terms of mean squared error rather than variance. It could be a biased estimate, but one might be satisfied with relatively small mean squared error or absolute mean squared error. Okay? So, we strongly encourage you to keep this problem in mind, that here is an open problem, there are solutions with probing, without probing, but there are problems. Okay? I will stop now. Thanks for your attention. So, let me briefly make a summary of what we have tried to do here. Shubhro, I hope you enjoyed our discussion on a very uncommon topic. Not only uncommon, it is a bit tricky, that the problem is estimation of the sample size, estimation of the population size of a finite population. It is a well defined population, but unfortunately the population units, we do not have direct access to the units. It so happens that I can only access them through a network, well connected, well established network involving these units in one place, and some reference population units on the other side. The reference population units can be accessed very easily. We can do sampling on them. We can think of a network, the population network, sample network, and try to catch the total size of the ultimate population units. As you could see, this is highly non-trivial scenario. The results are also a bit tricky, and there is scope for doing further research in this area. We will now take up some exercises and MCQs. Okay, let us take up the questions one by one. The first question reads like, create a population network involving capital M equal to 10 reference population units and the total of capital N equal to 20 ultimate population units. You are at liberty to frame the population network connecting the two sets. Draw an without replacement sample of 4 reference population units and reconstruct the sample network of the ultimate population units based on the selected reference population units. You have the entire population network. You first draw a sample of 4 RPUs, reference population units, and then you find out, reconstruct the network based on your sample. That is the whole idea. In the sample network, you will be finding some of the ultimate population units captured, and you also have the resulting network. Adopt probing, because you know the whole population network, you can do the probing and you can see the result. Extend the sample network, suggest n hat based on the data, and part B, suggest n hat based on the data without probing. Simply trying to see that you understand the theory that has been discussed and the computations that have been followed, so that you are comfortable in doing the computations, starting with a network on your own. Next. Okay, examine the formation of the unbiased estimator for capital N based on the data with probing, the relatively simpler scenario. With reference to question 1, once the sample of the reference population units is drawn and the sample network for captured ultimate population units is established, consider subsampling of a few ultimate population units and then go for probing on them. In the text, what we said, I have a sample of reference population units, through them I capture so many ultimate population units and I go for probing to all of them. Now, we are saying you have a sample of ultimate population units, take a random subsample, and on that subsample you go for probing. Work it out for a sample of 4 population units of your choice, thereby examining the collection of the ultimate population units so captured, and then by drawing a subsample of ultimate population units of suitable size. If you got 5, you take 3, for example. If you got 6, you take 4, for example. Do something, and eventually carrying out probing only on them. So, you know the problem now. You are exposed to a part of the sample network, even if you are going through probing, because not all ultimate population units are involved in the probing matter. Probing only involves a subset of the ultimate population units so captured. Now, what is your estimate of capital N? That is question number 2. Question number 3, create an example to demonstrate that for a given sample, capital N hat may turn out to be less than capital N based on data with probing. Here again an interesting question. We are saying that for with probing the expression is simple, the expression for capital N hat is routine computation. Still, you may end up with this unpleasant scenario that capital N hat becomes less than small n for some sampling, even though it is with probing. You are supposed to create an example. Okay? We have some multiple choice questions. Please read.
It is possible that a population network of reference population units versus ultimate population units is disconnected. If this happens, it is impossible to provide an unbiased estimator of capital N even with probing. Is this always true, always false, or depends on the network?
Very interesting question. It says that the population network itself is disconnected. So, these are the RPUs hooked to these ultimate units. These are the RPUs hooked to a separate set of ultimate units and so on. Disjoint. Disconnected means they are basically disjoint. But you are doing a sample selection of RPU and then you are going for the probing, everything is as usual. Is it possible to provide an unbiased estimate of capital N in such a context of disconnected network? That is the question. What is the next one?
In usual notations used in this module, for small m equals 1, capital N hat is more than equal to n without probing.
With probing.
With probing.
Yeah.
Is this always true, always false, or depends on the network?
Very good. This time it says you select only one RPU, okay, only one the reference population unit, and over there you whatever number you found, so small n of them you go for probing and apply the formula. Then do you find that capital N is at least as large as small n with probing? These are the scenarios. What is the next question?
The usual notations used in this module for m equals 1 and n hat more than equals small n, with subsampling of UPUs and probing.
Okay.
Is this always
the
true?
same type of question? Earlier in question number 2, you are talking about taking all the ultimate population units captured in the sample. Now you are talking about a subsample of the ultimate population units. But in both the cases, you are allowing probing. So in this module 15, we took up the standard problem of estimation of the size of a finite population, but in a very non-standard situation, namely the population units are not accessible directly. It is not like a household survey or survey of industries, etc. The population units, the reference population units are there, and it is through a network of the reference population units and the ultimate population units that we can have an access to the ultimate population units to some extent. And therein we had the concept of probing, no probing, ultimately estimation of the size of the population, non-trivial formulae, but then there are lacunas in the sense that the computational difficulties are there. Not that computationally these are difficult to do, but you end up with some frustrating results, namely capital N hat will be less than small n, that will be at times that may even be negative. So, these are the frustrating results. That shows that yes, there is a scope of taking up this problem again and working on something. Maybe we should do away with unbiasedness, think of reasonable estimators with good small sample property in terms of small or relatively acceptable mean squared error or relative mean squared error. This is a topic which is quite fertile even now. Okay, we will stop.